Hello class. Today, in this video, we will be talking about polynomials. You can think of polynomials as simply adding and subtracting power functions. And if you'll recall from last time, a power function takes the form f of x equals kx to the p. K, your coefficient, is a real number. X is your input, it's your variable. And P, the exponent, it's also a real number. Polynomials, like we said, you add these power functions, but these power functions will have specific criteria. So here we have coefficient. We'll just use a sub n for any real number. X to the n plus a to the n minus 1, x to the n minus 1 plus dot 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 a sub 1 x to the 1, or just x, plus a sub 0, and x sub 0, that would just be anything to the 0 power would just be 1, so it's really just a constant term in this last term, constant number. Okay, this specific criteria, though, about polynomials is that your n here must be greater than or equal to 0. All your n's, all your exponents, which is different from p. The p could be, a -1, a -2, could be a 0.5 or a 1/3, but here you must have non-negative integers. You can have 0, as in you can have a constant function that's a polynomial. It's made up of just one term. But you couldn't have, for example, a square root of x term. You couldn't have a 1 over x term, whereas you could have that in a power function. Okay, let's add some terminology to polynomials. Well, we can just look right here. So this whole thing, a sub n, x to the n, that's called your leading term. And so this whole thing is your, you can go ahead and leading term. Okay. And then that a to the n, that would be your leading coefficient, and this n here, that's actually called the degree of your polynomial. So you generally write your terms in decreasing order of the exponent. For example, a quadratic function, it's a polynomial. So if you have something like f of x equals 2x squared plus 4x plus 2, then your 2 would be your leading coefficient, and this 2 here, that's your degree of 2. Okay.